Okay, geometry. Here is a video about writing equations of lines, specifically parallel and perpendicular lines, and then talking about how do you actually write the equation of a perpendicular bisector. So if you remember, one of the main things that you need to write the equation of a line is a slope, the slope of a line. Slope of a line, if you remember, can be really steep. It can be really flat. It can be vertical. It can also be horizontal. Okay, so we're going to write the equation of a line, but we're going to start with slope. So if you remember, slope, I label these x1, y1. And the formula x1, y1, x2, y2, duh. And the formula for slope is y2 minus y1 over x2 minus x1. So I get 9 over 10. I'm going to show you really quickly how to do it by a table and also how to do it by a graph. So when I'm doing it from a table, I subtract that minus that. 5 minus negative 4 and I get positive 9. 3 minus negative 7 and I get negative 10. And it's always the change in y over the change in x, which would be 9 over 10. The last one is we plot them. Whoops. Negative 7, negative 4. And negative 4, 5. Sorry, 3, 5. And I can create the rise and the run. This would be my rise. This would be my run. So I rise 1, 2, 3, 4, 5, 6, 7, 8, 9. And I run 10. And so my slope here is also 9 over 10. Any of these ways work to find the slope. There are 4 different kinds of lines. A line going up to the right would be a positive slope. A line coming down to the right would be a negative slope. A horizontal line would be a 0 slope, and a vertical line would be an undefined slope. Okay, the thing you need to remember about parallel lines those lines are parallel. They will never intersect. The slope of parallel lines, M stands for slope, we know that's parallel, are equal. The slopes of parallel lines are equal. Let's look at perpendicular lines. The slopes of perpendicular lines are opposite reciprocal. So the slopes of perpendicular lines are opposite reciprocals. So I want to see that you can see this. So if you notice, this green line is positive. The perpendicular obviously has to be the opposite sign of the green line. Purple line is negative, green line has to be positive. Opposite. Okay? So opposite reciprocals. what does opposite reciprocal mean? It means that if I have a slope of 2/3, the perpendicular slope would be opposite sign reciprocal. If I have a slope of 7, -7, the perpendicular slope would be positive 1/7. Because remember, there's always a denominator if I don't have one visible. Opposite reciprocals. Change the sign and flip it. So let's remember that the equation of a line is y equals mx plus b. This is called slope-intercept form. Where m is going to be the slope and b is going to be the y-intercept. So if I were to tell you the slope of a line is -1/5 and the y-intercept is 7, the equation of the line would be y equals -1/5 x plus 7. But what if I were to tell you that the slope of the line is 3 and it goes through the point 5, 7? Well, if you remember back to algebra, I have a slope and a point and a slope, a point and a slope. I'm going to use what's called point-slope form, which is y minus the given y equals m times x minus the given x. So I'm just going to take my m and plug it in for m, my x and plug it in for x, and my y and plug it in for y. So I will get y minus 7 equals m times x minus 5. And if I was asked to write it in point slope form, I would leave it right like this. If I was asked to put it in slope-intercept form, I would solve for y by distributing the 3 and adding the 7. Slope-intercept form, point-slope form. Okay, so make sure you write down the steps in this example so that you can do this tomorrow in class. I want to write the equation of the line that goes through the points -3, 5, and 9, -2. So the first thing I need to do is find the slope. Slope is referred to as m if you remember from last year. So this is going to be my x1 and my y1. This is going to be my x2 and my y2. And the slope is going to equal the y2 minus the y1 over the x2 minus the x1. I have a double negative here, so the numerator is going to be -7, and the denominator is going to be 12. There's my slope. Now, again, I have a point and a slope, a point and a slope. I could use this point, I could use this point. It doesn't really matter. What matters is I'm going to put them into point-slope form. Y minus the y I'm given equals m that I'm given times x minus the x I'm given. And I'm going to plug them in. So I'm going to plug in the m, and I think I'll use this x and this y. So y minus the y is the slope times x minus the x. That will become y minus 5 equals -7/12x plus 21 over 12. I'm going to add 5. And I get 81 over 12. So this is the equation of the line that goes through these 2 points. Okay, now I'm going to add 2 more things that you'll need to do. First, I want to write the equation of the line that is parallel to this line, but it goes through this point. So I know parallel has the same slope. So I have a slope and I have a point. And I'm going to plug it in again to point slope form. Y minus the y I'm given equals m times x minus the x I'm given. And that's a big old plus. So I get y equals negative 7 over 12x because I distribute to here. If I distribute to here, I'm going to get 0. If this is a plus, I'm going to subtract it to the other side. That will be the equation of my line that is parallel to this one, but it goes through this point. Last but not least, perpendicular. Perpendicular. So with perpendicular, I also have a slope, but it is going to be the opposite reciprocal of this. So I'm going to change the sign and flip it. And I also have a slope point. So again, y minus the y I'm given equals m times x minus the x I'm given. And if you solve this for y, you'll get 12 over 7x minus 6. Okay, one last thing. So I want to write the equation of a perpendicular bisector. Here is my segment. I want to write the equation of the perpendicular bisector to this segment. How do I do that? Well, the first thing it needs is a slope. I'm going to write the equation of a line, right? Well, I like doing rise over run. So if I were going to do rise over run, my slope is going to be 1, 2, 3, 4, 5, 6. And then it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to simplify that. 3 goes into both of those. So the slope of that line is 2 over 5. I want the perpendicular bisector. So the perpendicular bisector slope is going to be the opposite sign and flip. So that's going to be my new slope. I know I need a slope and a point to do this, but what particular point? What is so important about this right here? Bisector means it has to go right through the middle. I want a line to go perpendicular right through the middle. What is the middle called again? The middle is called the midpoint. And to find the midpoint, I add the x's and average them. So negative 9 plus 6. And I add the y's and average them. So my midpoint is going to be negative 3 over 2 and 10 over 2. And let's see what that looks like. negative 3 over 2 is negative 1.5. And then I'm going to go up 5. 1, 2, 3, 4, 5. Right there. Does that look like about the middle? It certainly does. So that means my midpoint. So if I want to write the perpendicular bisector, I need a slope. I have that. I also need the midpoint. I have that. Once I do, I just put it into point slope again. So I have y minus the y equals the slope times x minus the x. And I will solve that on the next page. So I'm going to distribute the negative 5 over 2, but I'm remembering that this right here will become a plus. So I distribute the negative 5 over 2 to the x, and I also distribute it to the second term. So when I multiply from here to here, I multiply negative 5 times 3, I multiply 2 times 2, across the top, across the bottom. Now I'm going to add 5. And this will be the equation of my line. So last thing I want to do is I want to plot this line to see if it even looks like it's the perpendicular bisector. Remember we said that negative 1.5, 5 would be our midpoint. So I'm going to graph this as close as I can because we have fractions. And this point right here is my y-intercept, which is about 1 1/4. So that's going to be about right there. And I'm going to go up 5. 1, 2, 3, 4, 5. And backwards 2. So I'm going to end up right there. And if I put my line, let's go down 5. 1, 2, 3, 4, 5, 1, 2. So about right there. And if I were to put my line through, it looks like these are not only perpendicular, but it looks like it goes through the midpoint, which cuts this half and this half right in the middle. How do I know they're perpendicular? Well, I know that from the slope. The green line has a negative 5 over 2 slope. The pink line has a positive 2 over 5 slope. Opposite reciprocals. That's it.